So we're going to get talk about compiling software. And so software starts out as source code, and a lot of the work in the Linux community is creating that source code. So we have open source projects available. They're out there. We talked about GitHub. We showed you how you could get software repositories from GitHub. But what do we do with it once we have it? So I'm going to show you just a very simple um, operation here. We're going to compile some programming code in a very simple way. And now um, I have let's see, I have downloaded something from GitHub, and I'm going to go ahead and go into my Git project folder and look at the bits of bytes, and then another program here. This is a CPP program to get CPU usage from the command line. Right, so this is the simple program. I've already tested it and compiled it. We'll look at the source code real quickly. And this is just designed, it's not designed to be a really complex program, although it is a little bit long. Um, and so just going through that, if you've never really looked at C code, don't worry. But basically, what happens is what's going on is it's going through and it's finding header files, and then it will go through and begin to create the different types of objects that the program needs, variables, and everything. And eventually, we get down to this function called read state CPU, and it's actually in the process of reading the information about the CPU, and so that's a function where it will communicate with the kernel of the operating system and get that information. And then it goes through the next part, which is where we print the stats. And so we actually print that out. And that's all this program does. It reads the data. It sets up a place in memory for the data to be stored. It reads the data from the kernel, and then it outputs the data. So what we do when we compile code, we just have the source code. Is we use now in this case I could just compile with the main.cpp, but I noticed when I look at this particular folder, there's a script in there, and that's called build.sh. So instead of just blindly running a script, which is a security violation, right? I don't want to just go and, oh, there's a script there, I'm going to run it. No, I don't do that. I'm going to go ahead and look at the script, and what I see um, is that I essentially have two commands in this script. One is my GCC or G++ compiler with some declarations about what I'm actually coding, and I'm taking this essentially I'm taking this source code and I'm compiling it twice. Once in a CPU usage debug code and once in a regular one. So we're going to do that. It shouldn't take long at all to do it. And now when I execute a script, I have to start in this folder. So that period means here. It always means here. And then I put in my name of my script. That means that I'm going to execute that script. And so now my compiler runs, and it ran both times. And what I end up getting is the two files, and I can look at those files if I want to. And what I can see about these two files is that they are binary files. And I can see that I modify them and change them right now. And I'll look here and I'll just use a file command and we'll look at both of those files to see that they're 64-bit executable binary. Now the ELF means that it is an executable file. So it is linked. We can see the interpreter that was used to link it. We can see the shared, this file right here is a shared object that is used um, when the program is run. So what we'll do here is we'll go ahead and run that program. So I'm going to again do the dot and the forward slash because I'm going to execute the program. And there we go. I get to see my CPU state and the idle percentage. And if I run it a couple times, obviously I get some different values. I'm going to go ahead and run the other code too. Now remember, this was coded with a couple of different parameters. But it doesn't really look like there's anything any different about the code itself. So the author did include a link to an article in the README file, which we could look at and go to if we wanted to. But it would give more information about that program. Now this is very simple code. We compiled that code. We've created an object file. The object file get then turned into an actual executable file. So that's the way that works, and we can do that in any other code. So I actually have some more code. We'll go and look at another project. Now it gets a little more complicated when sometimes we get to larger projects. So we're going to go into another project here, and so in the case where I didn't actually clone this particular project from GitHub, but I did download the source off the internet, and this is QGIS. Now QGIS is a humongous application. Okay, it's very large. It's a mathematical package, a geographic information system package. So it's very big, but this is source code for that particular package. And we can actually go into the source folder, and I mean you could see all the different modules that are there um, for this package. So all of these are user interface elements. Um, the package is it's extremely large, but one of the things that I have in this particular folder is this what's called CMake list. So when I see that, normally I would see something like makefile. And what the make is a program that I run that is essentially a preprocessor, and it goes and finds things on your system, and it basically gets all of the settings for the compiler ready to compile the code. And so in this case, I would normally, if I saw a make file, I would just do make, and the make would run, and it would run everything. And I don't think I have, there's no make file here, right? So that's why I said no target. But then I would do make install, and that would actually go through the process of compiling the code. And it would sometimes take a long time. Now, this particular file we see is CMake. So I have another program that's called CMake installed, and I'm going to give it the parameter of the make list file. Now what I get here is an actual in-cursive output screen for the CMake. And I'm going to go ahead and hit configure. And as you can see, it's beginning to go through the script and it's going to look for different types of things on my system. And so it says there's no project command present. Top level CMake file must contain the literal direct call of the project command. So this is actually giving me a list of things to do. Now I may not want to do those things, um, but I would go through, as if I found errors here, I would go through and debug this. And as you can see, what has happened is so far in the process is this program has developed some compiler directives and some working directories that it would actually pass to the compiler, and I could go through and modify those. So we're going to go back, and I'm going to look at the main CMake list. Now, this was not here before. I'm going to go ahead and remove them, and this is what it looked like the first time I ran it. And I'm just going to go ahead and tell it to configure. And it's going to go through that process. Configure incomplete, errors occurred. And so I have two log files that I would look at. If I was trying to compile this software, I would go through the process of looking at those log files to see what happened. And if you notice, we'll look at those log files here shortly. But if I press E to exit, now notice that it has gone through and it has built these compiler directives. And I can go down through this list and I can edit uh, these values. So notice that I can turn them on and off. If I really want to override something, I can do that. I don't know what that is. So I'm not really a person that would need to go make decisions, right? But um, I could go through and do that. So that gives me the ability to look. Now I'm also going to look at the error log here, and just so you can see that. So here's my error logs, and we're going to look at both of them. And I'm first going to look at the output log, because this is something I would probably want to look at um, if I wanted to kind of find out what happened. So I would process this file, line by line, especially if I was new to the project, and I would begin to just read it. And I'm looking for things that are wrong. So the more I know about the project and about what it entails, the more I'm able to make decisions about what goes wrong when the software compiles. If the software is properly done, in most cases it can generate some errors or warnings, but it still compiles properly. So it's interesting that this particular software did not compile properly. But I'm going to go ahead and look at the error log as well. And I just want to do this to show you, so that you can see it in action and not be afraid of it. The biggest thing in Linux is that you can't be afraid to open a file and read it and see what is going on and start asking some questions, right? So here is an actual problem. It tells me that I'm going into this folder, this CMake temp, and I'm starting to build this object. And this is the output file that I'm making. And what happened? I got to a point where OpenCL was referenced, and it says, I don't know where that is. I can't find it. So What I would go do if I wanted to really get this program working is I would go find out where that code is on my system and make sure that I could point it to the right place. And that was the first hurdle. Now I'm sure that there would be many, many other hurdles to go. But I could eventually get the program, get rid of enough errors where it would compile. So that is the software compilation process. And of course, this is where that you would, if you couldn't find out what to do, you would submit a trouble ticket or look through documentation to get past those problems. So that is software compilation, and what you will do as part of your assignment in your logbook is you're actually going to clone my Get project, and you will both compile the code that's there in the project, and you will make some edits on that project as well. So, and I'll show you that really quickly. Let me go and look at the file editing process very quickly. So I'm going to go uh, into my temp folder, and I'm going to open up my. I'm going to go ahead and compile my math program. So GCC math. I'm going to call it math. Dash O for output. If I omit the dash O, I'm going to get an a.out file, which is easily runnable as the program itself. So I just execute like any other with 2 digits, 3 and 4. And then there is my code. Now what you'll want to do on yours is maybe modify it at some point to change your name. And you will go in and actually open that up in VI, edit the file, and recompile it. So if I were to recompile it, and then I could use the here /, and that tells the system that it wants to execute that file. Enter 2 numbers. There you go. Right. So there's the little program that we can test and run. Make sure we can compile code and get some output. But that's just a short example. Now, of course, I'm not a software developer, right? So I'm not in the world of troubleshooting compiler errors and all that. I'll leave that for other folks. But just to be able to compile some simple code, that's something that everybody needs to know how to do. All right, and as you get through this, don't be afraid to try things, do things, and work with your system.